Buongiorno a tutti e benvenuti a questo nuovo webinar che quest'oggi SRA organizza insieme a PAC. Quindi oggi parleremo e cercheremo di capire se eseguire l'analisi dei gas è semplice e lo faremo insieme a Fabrizio Ghisolfi che ci introduce il webinar. A seguire avremo con noi Teo Bochet e Arian Van Zip e in particolare Teo andrà più in dettaglio nella presentazione del software, ci darà tutte le indicazioni, ci mostrerà le novità e al termine ci darà anche qualche dettaglio in più rispetto alle principali funzionalità. Come sempre il mio compito è quello anche di ricordarvi che se avrete delle domande le potrete porre attraverso il pannello di controllo che potete vedere sulla piattaforma GoToWebinar. Quindi non mi resta che passare la condivisione a Fabrizio per iniziare il nostro webinar. Grazie a tutti.
Buongiorno a tutti, è un piacere incontrarci o rincontrarci eventualmente, perché con alcuni di voi è stata l'occasione ieri alla plenaria dell'Unichim per scambiare due parole, oltre a assistere, diciamo, a interessanti presentazioni. Abbiamo scelto con un nostro partner storico di qualità, del quale sottolineiamo sempre l'elevata qualità, facente parte del gruppo di PAC, Analytical Controls, in questo caso produttore di elevata qualità, di analizzatori dedicati al mondo industrial, in particolar modo al petrolchimico, analizzatori dedicati a tutto lo stream di prodotti, quindi dai gas al crude oil. Abbiamo voluto dedicare questo momento a una rivisitazione di tutte quelle che attualmente sono le loro applicazioni appunto dedicate all'analisi dei gas e ovviamente visto il mondo di applicazione a gas, a prodotti gassosi caratterizzati tipicamente da un potere calorifico e da una buona quantità di composti presenti al loro interno. Nel titolo abbiamo voluto nascondere un po' di ironia, anzi in verità rendere evidente un po' di ironia, in quanto si dà per scontata la facilità dell'analisi dei gas, cosa che voi meglio di me potete immaginare, appunto il livello di ironia nascosta all'interno di questa affermazione. Perché lo sapete bene, il gas a volte è puro, ma spesso a volte è impuro, ha tracce di acqua, ad esempio, piuttosto che di composti o polveri indesiderate. A volte dobbiamo gestirne una troppo alta pressione, a volte una bassa pressione, pressione incapace di vincere una linea di campionamento. Inoltre, tipicamente l'analisi gas in ambito industrial è caratterizzata da extra richieste, non soltanto una quantitativa, ma diverse unità di misura, diverse proprietà fisiche da esprimere, post rielaborazione, caratteristiche che metodica per metodica richiede diverse a fine analisi. Non solo. Tipicamente ci troviamo all'interno di uno stabilimento che ha delle regole ben precise, tra le quali ad esempio la modalità di creare un report e come distribuire all'interno dell'azienda eventuale report, quindi conformità a una piattaforma LIMS richiesta tipicamente dall'IT manager, ma anche all'interno di uno stesso gruppo spesso e volentieri troviamo diverse piattaforme LIMS, di conseguenza dobbiamo riuscire ad adattare la reportistica a quanto richiesto dal gruppo. Perché ci troviamo comunque a parlare di analisi gas? Nell'ambito industrial rappresentano una percentuale elevata degli analizzatori venduti e proposti sul campo, siamo all'incirca al 50%, analisi gas fondamentalmente dedicate a due tipologie di campioni, RGA ed NGA. Da qui la presentazione del nuovo software che PAC ha prodotto non rivisitando il vecchio software, ci tengo a dirlo, ma aggiungendo l'ultima piattaforma, come per quanto riguarda la linea di prodotti di HA o di distillazione simulata o i reformulizer ad esempio. Anche in questo caso ci appoggiamo all'unica piattaforma Iris e di conseguenza a una struttura del software che ricorda fondamentalmente assomiglia per alcuni aspetti a quelli che già state vivendo grazie alla nuova piattaforma. Lo scopo di una nuova piattaforma, nuove caratteristiche, nuovi benefit sicuramente, considerate l'introduzione di tutto quello che sono i calcoli richiesti dalla metodica ISO 6974 parte 2, quindi per il gas naturale. Ad oggi è l'unica piattaforma sul mercato, sia cromatografica che di calcolo e definizione dell'incertezza come richiesta da metodo, ma l'esigenza anche di passare a una nuova piattaforma in quanto quella vecchia non ha riscosso probabilmente tutto il successo che l'applicazione in sé meritava. In quel caso l'essere conformi all'ISO 6974 parte 2 necessita di un foglio esterno di calcolo, questo comunque rappresenta un limite e abbiamo per indagine, sappiamo da indagine che pur essendo accompagnata tutti gli strumenti RGN già venduti ad oggi, in molti casi non viene utilizzata, ma le calibrazioni vengono fatte su data station e i calcoli vengono eseguiti esternamente. Questo da parte del produttore la necessità di conformare a più elevati livelli di qualità la nuova piattaforma. Oggi Tio Bocché ci regalerà, tra virgolette, visioni della funzionalità sia del software che ripercorrerà quello che è il portfolio di PAC dedicato alle analisi dei prodotti gassosi in ambito NGA-RGA, mostrandoci le conformità alle varie metodiche degli analizzatori nonché del software. Credo che fermerò qua la mia introduzione e lascerò ora la parola al mio collega Tio Bocché, che ci mostrerà sia il portfolio che le caratteristiche di questa nuova piattaforma.
Tio, perfect. Oh, okay.
Yeah?
Yeah, we can see.
All righty.
Thank you.
Thank you very much, Fabrizio, for the introduction. My Italian is not that good, but I think I bit understood of what you told, and you gave already a nice summary of what I'm going to present. So thanks for that. My name is Theo Bouquet. I'm with PAC for a long time already, and I'm into the applications business. And today we're going to talk about gas analysis. And I've given the presentation the title "Gas Analysis Easy," right? Question mark. So that's what we will discuss during this this session. Now it should move. Yeah. So first gonna give an introduction to gas. What is it that we actually talk about and about the analysis of it. Then something about the market. Give you an overview of what PAC offers in terms of gas analysis. And a significant part will be the reporting and the calculations after the gas analysis. And of course, at the end, there will be an option to ask questions. And I will give a short demo of our latest software on this topic. So first, the introduction. I found this one interesting, that someone told me at one time that it was a Belgian guy who came up with the name gas. And this is Latin, and maybe for you speaking Italian might be a bit easier to understand than for me, but he, one way or another, came across something vapor-wise, and he decided to call that vapor gas, similar to the word chaos. And when we talk about gas and talk about chaos, basically gas is of course one of the fundamental states of matter. You have liquid, you have solid, you have gas, and you have plasma. And the difference between the gas and the other states of matter is that the molecules are far from each other and in moving around in a kind of chaotic way. The molecules that we talk about could be individual atoms like helium or hydrogen, or it could be a combination of different atoms like carbon dioxide or carbon monoxide or something like that, or Now you can think about examples yourself, or it can be a mixture of different components, different pure components. And mixtures, you can think about a lot of them, like air, which is a combination of oxygen, nitrogen, a little amount of CO2, etc. But also gases as they float around in a refinery. So that's a bit of what a gas is, one of the fundamental states of matter where the molecules move around wide from each other and in a kind of chaotic way. If we look to, it's going too fast, to our industry, which we call the hydrocarbon processing industry, I have divided them in 3 types, one being natural gas, one being refinery gas from different processes, and then the petrochemical gases from petrochemical sites. If we look at natural gas, that is mainly methane with lower concentrations of the other alkanes in there, and maybe some low concentrations of nitrogen or carbon dioxide. What is good to know about natural gas compared to the other gases, that it does not contain olefins, it does not contain unsaturated components, because olefins are made when you treat products, when you crack products. In the natural gas part, there is also the condensate, which is something, let's say, in between gas and a crude oil going up to carbon number C30 or something like that. If we go to the refinery processes, well, you can imagine that there are a lot of different gases floating around in the refinery, and the composition may vary from fuel gas having different components like hydrogen in there, or the hydrocarbons and so on. A typical gas, not really a gas, but liquefied petroleum gas, LPG, is a mixture of propane and butane, which are by itself gas, but if you put them in the container and if you increase pressure, they become liquid. And then the petrochemical processes, typically the olefins like ethylene and propylene gases, but also others. I will not talk too much about the petrochemical gases in this session. We may do that in another one. For now, this presentation will mainly focus on natural gas and the refinery gases. If we look to gas analysis, it's like every analysis done in a laboratory. You have a sample, you analyze it, and you calculate the results. That's pretty straightforward. And you could say, well, this is relatively easy because we are not talking about that many components in a gas. If you think about a gas up to C5, C6, you can talk about 20, maybe 25 components, and that's about it. But these components have a very wide boiling point range, varying from minus 253 for hydrogen up to, if we include hexane, 69 or pentane, 35. So that's a wide boiling point range, and you may require different type of columns to separate these components. Typically, mole sieve used to separate oxygen, nitrogen, or helium, hydrogen. PAC, HACCP type of columns for the separation of the CO2 and the lighter hydrocarbons, boiling point columns, and for the somewhat heavier components, and so on. So different columns are needed to separate, such a relative simple composition product. Sample introduction is another thing. How does the sample come to the lab? What is the pressure in there? Is it a gas or a liquid like LPG? Is there water in there? Are there any other contaminants? All items to take into consideration. And of course, like every measurement, the accuracy of it. And when we talk about natural gas later on, what's the value of that? And calculation of the results, based, for example, the calorific value or the heating value. And there are many methods describing gas analysis and gas analysis results calculations. And then You see a few of them over here. So many analysis methods, many calculation methods from different sources, ASTM, ISO, EN, DIN, etc. And they all talk about different metering conditions, atmospheric pressure, 15 degrees, 20 degrees, maybe in Fahrenheit, 60 Fahrenheit or something like that. And then the combustion conditions, ideal or real values, all kind of different calculations. Are we reporting in kilojoule or kilocalorie per cubic meter, per liter, you name it. And then as already mentioned, ideal versus real gases. So all kind of, these last two slides about gas analysis and the calculation of the results, where we say, well, it may be simple, but if you look in more detail, maybe not so simple. If we look to why would you analyze those gases, there are multiple reasons. Typically, composition analysis is what we do. And based on the composition, we calculate the value of it because of its heating content, for example, for natural gas. I will come to that in the later presentation. If you look to a refinery or petrochemical plant, with the fuel gases used or the components being gases being burned, the CO2 emission is important to measure, to report, because of different protocols in place. And of course, you have the process and the quality control. You want to know for your LPG, is it meeting specification, or how to optimize my process. And then more on the purity measurement for the more in the, let's say, petrochemical part, also for process optimization, for catalyst saving, etc. If we take a closer look to natural gas, used in a lot of places in our world, from power generation to cooking to warm our house with the central heating. Here in the Netherlands, we have our natural gas grid, and we use a lot of that gas to heat our houses. Or you see a lot of examples over here where natural gas is used even as a feedstock for petrochemical or fertilizers. And if we go to the value of the analysis of that natural gas, that's typically based on the calorific value, because the gas is used to burn and to generate heat, and the amount of heat is of course related to the composition, and that is where the price of the gas is based on. And when we talk about natural gas, we talk about large volumes. It's millions of tons going around the world, and you can imagine that a small difference in the calorific value result may end up in a huge difference in dollars at the end. And the criteria for analyzing and calculating the calorific value is based on the error or the bias that could be in that analysis. So a good accuracy, precision, reproducibility in the composition analysis, of course, of great importance. If we go to a refinery, this is a schematic diagram of a typical refinery, a pretty complex one, I would say, but there are many places where you could measure or should measure the gas. I've highlighted them here with the blue dots. There might be more even. And here just some examples of typical products when you talk about the FCC overhead or the fuel gas or the LPG, you name them, all different places for either process optimization or maybe even quality control. When we talk about emission, when was it, in 97, there was a protocol adopted during a summit in Kyoto in Japan about reducing greenhouse gas emission. And greenhouse gas like CO2 and methane may go out of the chimney or will go out of the chimney because you burn gases. It's an emission. And if you want to reduce that amount of emission, you want to know how much you emit, and that is based on what you use as a gas to heat your systems. So there is a need for monitoring the composition of the fuel gases, and that's described in the protocol and the need for the analysis. You can trade those values, etc. That's too much of detail to go in now, but the conclusion is there is a need for measuring the composition to reduce the emission of the greenhouse gases. Another one is, of course, product quality assurance. If you want to trade LPG, you want to know the composition of it. And that's done according to certain methods. And if you trade LPG or if you trade other gases, you want to know what's the composition on it. And if we all do it in the same way, then there is no dispute about how it's done. And well, if you use that method, the result might be different from other methods. So therefore, standardization comes in place where we have methods describing how to do it, and there is a mutual agreement amongst each other to follow that procedure. So these are just a few examples of why you would analyze gases and why you would calculate things like heating value or calorific value from those results. Let's have a look at the instruments that the analyzers that PAC, AC Analytical Controls, offers for a gas analysis. An overview, maybe not complete, but the main ones divided into three areas again: natural gas, refinery, and petrochemical, where for natural gas analysis there are, as already mentioned, many methods like the ISO 6974 or the GPA method. The Gas Processors Association has different methods. HTM has methods. We have some in-house analysis, but all for composition analysis of natural gas. For refinery gases, we have the refinery gas analyzer, our high-speed RGA, and the LPG analyzer. And the high-speed RGA, I will explain a bit more later on, is a very versatile analyzer, being able to analyze all the different gases going around in a refinery. And of course, the LPG analyzer is dedicated to LPG composition. If we look to petrochemical, there we talk more about the impurity analysis, ethylene, propylene being used for polymerization, and any impurities in there may affect the quality of the polymerization and result in different polyethylene or polypropylene quality. Many methods, again, I will not touch base on them right now. We're going to focus on the ISO 6974 3-channel AC natural gas analyzer and the AC high-speed RGA for refinery gas analysis. So if we look to the ISO 6974, that is a ISO method consisting of 6 parts on top of my head, where the overall title is the determination of mole fractions and uncertainties of natural gas components by GC. So it's about analyzing the composition of the natural gas and how accurate that is done. And you may recognize the pictures over here. You see a lot of them when you Google on precision and accuracy. Obviously, you're aiming for a high precision and high accuracy where every result is really spot on, accurate, and there is not much to variation. Like we have much more variation here. And here you have a good precision or but low accuracy. You're far away from your target, and this is even worse. This method describes, as like I said, has 6 parts, where part 1 is general guidelines and terms and definitions, etc. where part 2 is about the uncertainty calculation, which I will talk about later, and part 3 is about precision and bias. And that part was changed in what was in 2018, where a earlier version of that method was describing how to do the analysis, which columns to use, how to set up the instrument detectors, etc. Use PAC columns, and it was very descriptive in how to do the analysis. In 2018, with the update of the method, it went to something like, well, regardless how you do it, as long as you do it very precise and accurate. So no criteria on the hardware, but purely on the performance. And that gave AC at that time the opportunity to develop a natural gas analyzer, which offers a much better precision than what it was before, because we could use our own type of columns, our own design, etc. And that design is what we see over here. It's a 3-channel analyzer where we analyze the hydrocarbons C3 and higher on an FID. We have a separate channel using a TCD for air, methane, CO2, and ethane, and then the 3rd channel for helium, hydrogen, oxygen, and nitrogen. And these last 2 are obviously using a thermal conductivity detector. The change of the methods, allowing us to optimize our instrument, gave us a much better repeatability, as we will see, a much shorter analysis time. We could also analyze the wet gas analysis according to the ISO 6975 methods, and it also complies with other methods which are more flexible nowadays as well. So you could see this as our universal natural gas analyzer meeting those methods. 3 channels, 3 chromatograms, obviously obtained simultaneously. Channel 1, 2, 3, as you see over here, where you see your hydrocarbons, where you see your carbon dioxide, ethane, and hydrogen sulfide, and the helium, hydrogen, oxygen, nitrogen, and methane, where this is hydrocarbons are separated on a capillary column in the GC oven, where the other components are separated on micro-packed columns in an isothermal oven, and that isothermal oven is a big contributor to the precision of the analyzer. I'll show you later, but we are much better than what the old method was stating. Having your micro-packed columns in an isothermal oven means there is no change in temperature, and therefore the stability of that separation and the quantification is much better. We have an analysis time of less than 10 minutes, as you can see here, and we do a backflash of C6. If you want, you can take that out and you extend your analysis, where C6 and maybe traces of 7 could come out at a later stage. Looking at the performance, the ISO method gives you a requirement on the standard deviation, as listed over here in blue, where the performance of our system is shown in orange. And you can see they're all way much better than what the method is asking for. And here on the right scale, you see the typical concentrations of those components. But just to give you an example, methane, the standard deviation is, well, almost 10-fold better than what the method is asking for, which obviously has huge consequences for the precision and the uncertainty on the calorific value as well, which we'll see later. If you look to precision over time, we did around 30 analyses, showing you components, 1 from each channel, where the concentration is shown here, and you see that the standard deviation, plus and minus, it should be well within those lines, and well, it's much better than what is needed. Detection limits, we go down to 100 ppm for the inerts, so to say, in the methane and ethane, where the heavier hydrocarbons go down to 0.1 ppm. If we go to our next analyzer, the versatile high-speed RGA, a very broad sample scope, analysis done in 6 minutes. Cost-effective design means that it's, again, a 3-channel, as we'll see, allowing you to run single channels as well. Proven compliancy, we'll see the performance of it, and it comes with our latest software, which I will demonstrate at the end of this session. Kind of similar to our natural gas analyzer, 3 channels, 1 for helium hydrogen, 1 for the hydrocarbons, and 1 for the inerts. 3 channels working together simultaneously, or you can say, you know what, I'm only interested in hydrogen, and then you can do a 2-minute analysis where you only use this channel. So versatility altogether, just 1, like the hydrogen over here, or maybe just LPG composition on the hydrocarbon channel. Some chromatograms as it's produced by the RGA, hydrocarbons detected by an FID separated on a plot column. Here you see the analysis of hydrogen, and here we see carbon dioxide, H2S, oxygen, nitrogen, methane, and carbon monoxide. That's the standard setup, but with that same hardware, we can also run different methods. So same hardware, different methods on the same instrument without any hardware change or whatsoever. If you leave the backflows out on the hydrocarbon channel, you can also analyze BTX. So you don't backflush, and you see we analyze up to orthoxylene if you really zoom in. We have the option to analyze H2S and COS, not at ppm level. For that, you would need a different system, which our Sense2, our chemiluminescence detector, but on the TCD, you can still measure down to, what is it, 0.1%, something like that. And LPG, just the hydrocarbons. And for that, optionally, you can also add a liquid sampling valve for introducing the LPG as a liquid, where typically all gases are introduced as gas. If we go to the spec and the specifications as listed here in the method compliancy, different ASTM methods, different, or 1 ISO method actually, EN methods, and an IP, DIN, UOP method, all describing refinery, some type of refinery gas analysis. The dynamic range from 0.01 to 100 for the hydrocarbons, and you can read the rest here for the inert gases and the H2S, where we have a repeatability of less than 0.5% on the peak area. One of the nice features, and I will just highlight 2 of the features on the RGA, is that we control the sample introduction with the help of a sample shut-off valve. If you look to what goes into the columns is the content of the sample loop on the gas sampling valve. And the content of the gas sampling valve of the loop are the molecules that you introduce. So you can go back to the ideal gas law where PV is nRT, where the volume of the sample loop is fixed, the temperature is fixed, R is a known value, and the pressure directly relates to the number of molecules in the sample loop. So what we want to do is to do this as repeatable as possible, and we close the gas sample going into the sample loops once it's flushed enough, and then you stop the flow and you allow the pressure inside the loop to go to atmospheric pressure. and then switch the valve to introduce the components into the system. So having it always at atmospheric pressure improves the repeatability of the system. You can of course do that manually, but operators may act different and etc. And you may forget to switch, or you switch too early. In this way, it's all automated, and that's the result then of a good repeatability. If we go to the next option, that is the programmable 13X. We have a MolSieve 13X column in there, which takes care about the separation of oxygen, nitrogen, and methane and carbon monoxide. Well, you can say, well, this separation is not very good. Well, that happens over time when the moisture in the gas or whatsoever may deteriorate, may reduce the performance of that column. And to overcome that, you can condition the column. And typically that was done in the past by taking the column out, put it in another DC, warm it up for a few hours, put it back in, etc. A very cumbersome and time-consuming procedure. What we have now done, we have built a conditioning in there. It has its own heating, and you can, while the column stays in the system, for a couple of hours, condition the column using nitrogen as carrier, because that improves the conditioning. And in a few hours time, your separation is back to what it's supposed to be, as you can see here in the bottom. Here you have a nice separation without taking the column out, just starting a method, and everything itself is done automatically. This is how it looks like. It's just a picture of the hardware. This is the column oven. Of course, we have taken the cover off to show you the different capillary columns. And that MolSieve column is mounted in this piece over here, this mini oven, which allows us to heat up that column and condition it. If you look to the performance of the system, it's showing here unnormalized area repeatability. It's typical in refinery gas analysis that you normalize to 100% afterwards, but you can see that already on unnormalized, the repeatability is far less than 1% RSD. And again, I'm showing you every time 3 or 4 lines, one from each detector, that it's not only one channel which performs very well, but all the 3 channels. To set up the analyzer, and as you know, hopefully know, PAC guarantees their analyzer for the application you have bought it, so that's the application guarantee. We calibrate the system in our factory using certified calibration standards, calibration gases, and we ask during the installation to have a certified gas to be available so that we can calibrate and validate the system performance. We can offer you those gases. If you already have them, you can use your own, of course. Instead of making a lot of slides, I've just highlighted here a picture of our refinery gas analysis with topics that are important in the overall performance or the features used, like the automatic 13X column condition, the micro-packed columns in the isothermal oven. We use inert tubing to avoid absorption of H2S. We have the sample shutoff valve. We have the software included. We can extend the method up to C9. Of course, every system is factory tuned and validated, etc. So here, highlighting all the features and benefits of our refinery gas analyzer, the high-speed RGA. We make life, I would say, for SRA very easy with the installation by upfront, before we ship the unit, to set it up, to test it, to calibrate, and to validate it, so that once it comes on site, it's kind of ready to go. And the only thing needed to be done is to recalibrate. That's obviously needed because it's reinstalled, so you always need to recalibrate. We check it, we familiarize the user with it, and then we can say, well, when that is done or during the familiarization, we say, come with your samples, and we help you to analyze the first samples. That is typically done within 2 days. So very easy installation. So far on why and how to analyze gases, natural gas and the refinery gases. For the results calculation, we have recently introduced a complete new software package, which we call RGA-NGA Excellence, and it's part of our IRIS software, and I will show you later on. Why would you need such a dedicated software? Well, there are a couple of things you need to pay attention to when you calculate your results. You need, of course, to know how your instrument was configured. Is it 1 channel? Is it 2 channel? 3 channel? You need to calibrate it, single level, multi-level, 1 gas, multiple gases. We need to look to what product was analyzed. You may need a different report for one product than another product, or you can expect different components to be present. We may need to follow a method. So the method compliancy, is it the ISO 6974, or is it another method, one of the RGA methods? Do we want to report at 20 degrees or at 15 degrees or at 1 bar or at what temperature, etc.? All things that play a role in calculating the final results of the gas analysis. And as you can see here, our software incorporates all these items as just listed. And for each, let's say, bullet, I will show you 1 or 2 screens from the software, and later on I will show you the live software. So if we go to the instrument configuration, you can define the hardware, how many detectors are used, etc. And like here, what's the name of the detector? Do you want to automatically, after the analysis, process your results? Do you want to bring them in the system? Because it's good to mention, for analyzing the sample, we use the standard chromatography data system, typically OpenLab or ChemStation, but OpenLab is at this moment, I would say, the standard. After the analysis, sample can be automatically imported in our database, in our software, and results and composition are calculated automatically. The calibration, as I mentioned, you can have just 1 calibration gas with all components in there. You may have 2 calibration gases, as in this example over here, where we have 2 gases, one with H2S and methane, as we typically offer it, and the overall RGA calibration gas with all components in there. For each gas, you enter the values in the software, and you can even upload a copy of the certificate, and you tell the concentrations for 1 or the 2 or the 3 gases you use. And like you see over here, this is a picture of our RGA calibration standard components and the concentration. And later on, I will show you that you can enter the uncertainty as well, which we use for the natural gas analysis. And from then analyzing the 1, 2, or multiple calibration gases, we come to a calibration curve for each component, as we see over here. In this case, methane having 2 points, 1 here and 1 very high, because that's the balance of the H2S gas, and you can use that as well. And it shows you, well, all components are nicely calibrated. If one of your calibrations gases is expired, it will tell you because you have entered the expiry date. The products, you can analyze, of course, different type of gases, and each gas may have its different requirements in terms of reporting volume percent or mole percent, or you want to unnormalize the results or whatever. And you can enter those target values of what it should be for your LPG. For example, this is just something where you say your butane may have maximum 40%, whereas your propane has a minimum value of 40%. And your unnormalized results should be between 96 and 104. If you analyze the sample according this requirement, then it will tell you whether it's out of spec, so to say. And that's the same for the different calculations like shown here, the vapor pressure or the motor octane number, different values that you can enter there. And those values are used to check your results and tell you whether your sample is okay as per the parameters you have entered. If you look to the methods, well, there are a load of them. And ISO methods, EN methods, you name it, listed over here. And the software includes a lot of calculation of the various properties shown over here. The molar mass, the inferior or the superior calorific value in mole or mass, or the carbon content, or the heating value with the units as listed over here at the various temperatures. And that is very important to keep this in mind. When we go to the reporting, you can report at different temperatures, at different parameters, etc. So this are the methods all included, and over here you see for the different methods I will show you in the software the values of various temperatures, etc. And this data is used for the property calculation at the end. Then we have different metering conditions, temperature, pressure, and they can be used. You can set different temperatures for the different methods. You can change that, you can optimize that yourself. Data is in the database and will be used depending on your setting. The units you can choose yourself as well. Here, kilojoule per mole, or joule per mole, or BTU per mole, or kilocalorie. You can define the precision and whether you want to use it, yes or no. So these conditions, these settings, you select once you define a product, once you define a method, and that will then be used to calculate your results and will be shown in the final report, like just an example over here. Components, the retention time, and I've selected only mole percent and mass percent, normalized, but that could also be unnormalized in mole percent or volume percent, whatever you like. The metering conditions chosen over here, and here you see some results from different calculations with different units. And the different units and the different metering conditions, you can set that in a report. You can have, let's say, the molar calorific value reported at different temperatures by simply selecting it twice and select different conditions. And what you get in your report is drag and drop, like we are used to with this kind of report setups. So far about our, let's say, standard RGA NGA Excellence software, and I will show you in live later on. We have the option to add something to it, and that is the uncertainty, because for natural gas, we make the statement, knowing your uncertainty gives you a certainty. It may sound a bit weird, but if we go to what we talked about, that your gas analysis, your natural gas analysis is traded based on the energy content, you can imagine that the more accurate you do that, and if you know your accuracy, your uncertainty, you know what to ask for in terms of pricing. So like this, as an example, if the gas has a calorific value of 11 kilowatt per cubic meter and it's traded with an uncertainty of 0.1, it means that you sell it for the price of a gas with 10.9 kilowatt per cubic meter. But if you say, well, it's not 0.1, but it's 0.2, means you can trade it for 10.98, which obviously will give you a higher price. That may look not too much, but if you look to the ship or on the earlier slides, we talk about a lot of cubic meters of gas. And the ISO method, part 2, as I've mentioned earlier, describes the uncertainty and how to calculate the uncertainty as based on the analysis done. And that involves quite a lot of measurements and calculations. First of all, it wants you to analyze calibration gas at 7 levels, and for each level, a minimum of 10 repeated analysis. So that's already 70 analysis by itself to calibrate the system. In addition, they advise to analyze a working measurement standard. That's a kind of check standard stored with that calibration or linked to that calibration, and that can then be repeated, such a working measurement standard, at the moment you analyze your sample. And those two are then compared, and it tells you whether your system is performing well and you can trust your sample analysis. If you look to the methods, it's quite a few pages of formula and etc. It's not a very easy calculation. And typically that is done using, for example, Excel. And we still have that in the field. Excel sheets where you need to manually drag your results into, and how to get it out and how to automate this, and that are all challenges you may have with using Excel. And an important one, for example, is the traceability or the flexibility in the reporting. Well, you know what, with that nice ISO module that we have now available on our software as an option, it deals with all these kind of items. And I'm gonna highlight them in the coming slides. Here you see a calibration, multi-level calibration. 1, 2, 3, 4, 5, 6, 7 points for, in this, carbon dioxide as an example. And it gives you the calibration function. It shows you it's doing perfect. You need to do multiple analysis. Well, in my example here, I only have 6, but you see for each level, we have done multiple analysis. It's giving you the different individual results. And from that, it shows you how the results deviate from mean for every individual value. And you can indicate and exclude individual results if you want to, or if it's the software tells you, or better said, the ISO method tells you, you have to exclude. And each point here is represented in this graph over here, where you can see how it deviates from the mean value. So this is our calibration just for one level, but the multiple analysis. So that's the next topic. And then we have included the working measurement standard. Let's say the check standard. You can do multiple of them, and you see them over here. You can select which one you want to use. And when you go to your sample analysis, you select the working measurement standard or working reference standard, whatever names you want to use, and use that in your calculation. And then at the end, you come to a result where for the components, you have done multiple analysis. Obviously, it gives you the standard deviation, the relative standard deviation, and the mole percent, including the uncertainty for each component for that analysis. Not only for your components, but also for the individual calculations, like the gross molar calorific value, like you see here, or the net mass calorific value. So that's that 0.02 as an example I was talking about. And this tells you, this helps you in proving to your customers, well, this is the quality of our natural gas, and we have analyzed it with this precision according ISO 6974 Part 2. So that option, additional feature on the software, complies with the methods. It contains all the metering conditions. It's automated, so your results introduction, the calculation, etc., is all automated, and it validates the various functions. There is the working reference material correction in there. It shows the sample repeats and the limits for that. And a nice thing about it that also the option to do a pressure correction. So if you have the ability to measure your pressure at the moment of the sample, the atmospheric pressure at the moment of sample introduction, you can even include that in the calculation, which will improve precision even more. Just in a summary, some additional items about the software. Like I said, the pressure correction. Some methods may ask you for oxygen correction. If air was introduced during sample introduction, it can be calculated out by using the oxygen correction. Some methods ask bridge calculations. The peak identification, I will show you, is easy, drag and drop, and will identify peaks, individual peaks or groups. There is an unknown handling, and then of course the uncertainty and the error propagation calculation, the sample repeats and so on, as for the ISO 6974. Technical specs, Windows 7, 8, I was about to say 9, but 9 doesn't exist, 7, 8, 10, and 11. Hardware requirements, well, that's a DC of course, and the chromatography data system supported are basically every system which produces a CDF, a chromatography data file. And in terms of reporting, well, we have seen that flexible reports, automatic export to LIMS if you want to, and then you can create your own reports, your own templates. In addition, there is an option included, I've not listed here, but to add your own custom type of calculation. If you have that and it's not included in the software, we can talk about that, and we can include that, and it will be automatically reported as well. Brings me to the last slide of my presentation. So as a summary, we offer you a complete portfolio of gas analyzers for refinery gas, natural gas, petrochemical gases, LPG, etc. And they come with a piece of software which gives you all the extensive reporting options and calculations. And if you have the ISO 6974 option, then it also includes the uncertainty. And the title of the presentation was Gas Analysis is Easy, and I think we can answer that by now. Yes, it is, if you use our PAC software and equipment. Let me now, if that's gonna work, show you some of the software, or maybe do that first, see if that's gonna work.
Okay.
Okay. Arjan, we don't hear you. Arjan is asking Fabrizio whether there are already some questions in the chat box.
Can you hear me now?
No,
yes, you too. Yeah.
Okay. Yeah, just as Theo is setting up his system to show some software, Fabrizio, maybe it's good to check if there are some questions after kind of 45 minutes of presentation.
No, yes.
Laura, did you collect questions?
Yeah, I have 3 questions, so I can make the questions to you, and then if you want to share it with Arian and Theo, okay?
Good.
So, I do it in Italian. La prima che è arrivata ci dice se è possibile aggiornare i sistemi già installati alla nuova piattaforma, o vi sono limiti per quanto riguarda il data station installato, oppure limitazioni pertinenti all'hardware degli analizzatori?
Ok. Posso immaginare la risposta, e la risposta credo sia sì alla prima. Non so la seconda, ma immagino di sì. Ma adesso chiediamo conferma comunque a Theo. Theo, the first question is concerning, or sorry, Arian, the upgrades. So can we upgrade an existing, let me say, RG analyzers based on gas excellence with the new platform software, or the new platform is just for the new instruments?
No, you're absolutely right. No, it is for an upgrade as well for the existing software. And I think it's very important to tell you that the gas excellence software with Windows 11 is in principle no longer supported as well. So if customers are changing to a new PC in future, they need to think about as well upgrading their software. So that's one good thing as well with the new software. It will help and guide them through the current process very, very well, and it will have a benefit for them. So all the information is and will be shared with Eseguire, of course, and you can offer your customers those upgrades.
Ok, giusto per ribadire, Arian ha confermato la possibilità di poter upgradare gli attuali sistemi sul territorio, sottolineando un limite di gas excellence, cioè la penultima piattaforma, quella che tutti hanno, che non è aggiornabile al sistema operativo Windows 11. And the other questions left is there any limitation on hardware? Just to let you understand that in our field we have today a lot of 6890 present. Sure, customer knows that the limitation on the hardware is fixed by Agilent, but however this condition exists. So there are any limitation on the hardware for the new platform?
No. Indeed, there is no limitation on this. So our software works as together with the Open Lab or GAM Station, who creates a CDF file and makes that available for our software to pick up and do the calculations and the reporting tool with that. I think Theo will show you a bit more in his demo. He has got the software available for this.
Thanks. Second,
personalizzazioni, quindi aggiunta di calcoli non presenti al momento nel database, chi può eventualmente farlo, o personalizzazione di report per conformità alla esportazione, come ad esempio da richiesta del software LIMS del cliente o dell'IT manager. So.
Okay. Customization. Let me just spend a few words about that. In the last 10 years, we saw that with more bytes, we can do everything on a software, but we start to do that in a not easy way. The question is, customization is possible for, I don't know, to add the new calculations or to add new units, measurements, and should be done just by a service engineer from Eseguire, or well-trained, the customer can do it by himself.
Theo?
Okay, maybe I'll answer that one when I show the software, because then it starts to make sense than just explaining. Yeah. Yep.
Good. So we'll have an example of that.
We'll park it till. Are there any other questions?
Yes, we have 2 questions. So the first one is, Validazione dei calcoli proposti, hit in value per esempio, a fronte di analisi accreditate. Quindi il software è dotato di una procedura di verifica della bontà di calcolo o serve comunque un foglio esterno per la verifica? Questa è la domanda che fanno.
Okay, maybe as the previous one, Theo, you can answer during the demo, let me say. But however, the question is, in front of a validation test, I think about RGA, for example. Sometimes customer have to show if the calculation for eating value, for example, or CO2 content is correct in front of a test, in front of a standard. Is there an internal way on the software to show that, or as before, we have to perform it as a separate with an external calculation, Excel spreadsheet, something like that?
Well, that's not a very straightforward answer or a straightforward question. It's about validating software. I would say the most safe way of doing that is having a result of a sample, and to prove that the outcome is good is take the results of the analysis and indeed manually follow the formula as written in the method and see if the results compare to what the software produces. That would be the most safe way. What I know also is that people use calibration and then validation gases to check if the analysis itself, the performance is good. So if you have a calibration gas, you rely on that, obviously, but to have proof on that, you could have another gas with a slightly different composition or a different composition, maybe even from a different supplier, and analyze that and see if the values are matching. That would be a cross-check on the composition analysis. The calculation results, so for the heating value or whatever thing you want to calculate, is, I would say, take the concentrations as reported and follow the method and calculate manually.
Okay. Niente, diciamo, semplicemente si continua come si è fatto fino adesso, di conseguenza non si valida all'interno del software il calcolo, che in effetti potrebbe essere anche un controsenso, validare il software internamente al software, ma come già stiamo facendo, situazione per situazione, un calcolo esterno per riprovare che il calcolo del software è eseguito in maniera corretta. Abbiamo concluso le domande, Laura?
Sì, ce n'è, guarda, forse una che è arrivata, che ti ho condiviso adesso.
Scusami, ma parlando...
No, per carità. In acquisizione e analisi mi chiedono se c'è un campo dove inserire delle descrizioni aggiuntive del campione e poi siano visibili nel report finale che Iris, il software, quindi produce. Quindi
last question, Theo. Is there, I think so, but I didn't see the new platform. I didn't play with the new platform yet. Is there, as usual, a field, a comment field before starting the run where I can add notice or data about how I sample this sample with?
Let's check, Fabrizio. Let's check. Yeah. I don't know on top of my head either.
Okay.
Yeah. Yep.
Okay.
Good.
Yeah, go ahead.
I think it's the last one. You can go ahead, please.
Yeah.
And thanks for the answer.
You see my software screen?
Yes.
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 Good. So what we see here is our main screen from Iris, and I'm just showing this as well because you know what? There we are. Here we are. So we have Iris as a platform for all our AC, DC analyzer software packages. And you see I have a lot of instruments in here, varying from a reformalizer to an RGA and various indices. Let me start the RGA software. And there we go. And then I'll close this one to have a bit more space on the screen. So the look and feel of the RGA Excellence software is very similar to that of our other software. For those who are familiar using SimDis or Reformalizer or DHA, they will immediately recognize this screen. We have multiple tabs available for the user, where the result tab shows the analysis results as present in the database of our software. Well, in my case, I only have 5, which makes it very easy. But if you have hundreds of analysis, you have below here the option to put in filters for a specific test, for a specific product or a time, and it shows you only the result from that selection. If I take one and I do that over here, one click gives you a preview, and a double click opens the results. And what you get are in this case, it's from a high-speed RGA. I will limit myself today to the high-speed RGA demo. You will see 3 chromatograms, the FID channel, the channel for helium, hydrogen, and the one for the carbon dioxide and the oxygen, nitrogen, etc. I can open a second sample, and you'll see I can switch between the 2, and I can have multiple open at that time. What you see is the 3 chromatograms. You see the labels there, and if I go here and I simply click the select button, I can simply drag and drop. And what you will see, it's becoming bold, and it says, hey, something is not found, and I simply drag and drop it over there, and now it's recognized. It gives you the results and the area found for the components, for the area for the components found and the unnormalized concentration. So this is the identification part, and here you can play to show what you want to see on the screen, not found peaks or unknown peaks or etc. You can have different markers. You can have your signals. If you say, well, you know what, I only want to see the other 2, you can switch it on or off and so on. The results are shown here in the calculation tab, where you see your components. The unnormalized results, well, 100.77 is good. Mole percent, mass percent, gas volume percent, and liquid volume percent for each component found. And a lot of calculations selected in this case, according ISO 697, according EN, and some other miscellaneous factor, like for example, the CO2 emission factor, as I talked about, and the sealing density and so on. And you see whether we have used pressure correction, oxygen correction, or bridge connection. In this case, not, but that is all selectable from here. So select between the identification part and the results. If you want to create a report, you go to this little button over here, and I have no clue how I have set up the report for this one, but let's have a look. Apparently asked a lot, and with my connection, Teams connection being on, it takes a little longer in this case to load the report. There we go. It's initializing it, and there we have a report set up in a certain way, and how you set it up is customizable. So your components, in this case, I've selected mole percent, mass percent, and liquid volume percent. The metering condition, in this case, 15 degrees for the carbon content and the mass heating, and the CO2 emission at 15 degrees as well. Yep. So that is from this results. You see another tab over here, and that is the calibration tab, where we have, in my case, a calibration for high-speed RGA, and let me open it. And in there, I have two analyses. This one and this one. So you get your chromatograms, you do your peak identification, etc. You do that for both, and then you'll end up with this step for your calculation, giving you the curve, whether it's calibrated yes or no, showing you per line the curve, and it shows that for all components in there, everything is calibrated correctly. You can have different calibration gases for different tests. In my case, I have here 3 tests, defined 3 instruments, you could say. So that's on the calibration. Let's go through the various options. The signal and detector, well, as already mentioned, that defines how my instrument is configured. System components, that is like a big, let's call it a mother database with all components in there, their CH/ON/S ratio prepared for the future with the liquid density, the molar mass, and the compression factor. You can edit if you want to. If something is changed, and we'll see that, no, I will not be able to demonstrate, but if you change something later on in one of the parameters in a standard method, then it will highlight that you changed it and it's no longer according to the method. Test configuration, that's probably one of the most important. And let me select the RGA, which detectors to use, how to group. So you can group components. We say here that anything between here and here is defined as C6 PAC flush. The expected retention time, the window, etc. How to deal with unknowns, not so common in natural gas analysis, but happens. How to quantify, use pressure correction, yes or no, for some NGAs, bridge collection, oxygen correction. Component groups, you can create your own groups that you say, I want to see all my C4 olefins, and then you add and the components, etc., etc. For time concern, I will not demonstrate that now, but you can imagine that you can set up C4 olefins or C5 plus or whatever. How the graph will look like, which calculations are in this test available, and this is where you see the different tests, etc., with the units selection. Megajoule per cube and so on. The unit precision, so how it will be reported, how many decimals are there, etc., etc. And if you then come to the question, what if we have an additional calculation which is not in here? Then you have the option to add custom calculation. And basically what we do, we create an Excel sheet with that calculation, and in there the components used to calculate the results. And we should follow a certain template, of course, a certain setup. We import it in here. Once there is one, we say use template, and then the result of that calculation will be available for your final report. So again, if there is a calculation not included in the software or in a different way or whatsoever, it can be included by creating an Excel sheet according a certain format, which we import in the software, and that will then be used to calculate the results and going back into the RGA results and included in the report. You don't need Excel on the computer to perform this action. And then at the end, you have the option to define different reports, which can be set up directly from here, or if we go back to the menu over here, you can say report configuration, you can drag and drop from left to right components in or out and different calculations, etc. Last but not least, a few items over here. Here you define your products, where you say, well, you create it and you put your different targets in there for the components or for the calculations that you want to be part of the reporting. Then standard methods, the last two things I want to show. All the methods are in there. If we take EN 589, the motor octane number, the individual values, absolute heating pressure at 0, 10, 20, 40, the vapor pressure here, and so on, -5, -10, allowing you in the report to report according different parameters, different metering conditions. And every method has so its own variables in there. And if you want to, you can also have the sealing density, which is not according any method. And if you run the check button over here, it will tell you, well, you have changed something according the method and will highlight that in red. And then here, the standard metering conditions, which allows you to put in different values in this case. I'm looking at the clock, we have 5 minutes left. And of course, final LIMS export option, either automated or manual, where you can say, I want to set up the results according my wishes for how LIMS would like to result to be presented, and then the LIMS can pick it from a certain folder where the CSV or the text or the whatever kind of format you want to have. Just a quick glance, definitely not showing you all the features, but at least I hope to have given you a certain feeling and that there are a lot of options in terms of calculating and reporting results according to various methods. And I hand it over, I think, to Fabrizio and Laura to see if there are more questions.
No, we have no additional questions. Thank you, Theo, for your presentation.
Welcome.
I'm sure that it has been very interesting also for our audience. And I guess that you will be at their disposal for any questions they might have. So sure. Invito tutti quanti, qualora abbiate altre domande, insomma, di condividerle con noi. Vi aggiungo questa piccola cosa, ho condiviso anche la brochure nel pannello di controllo, la potete trovare, la potete scaricare. Scusami Fabrizio, poi ti lascio la chiusura finale, ricordo solo le ultime dettagli. Domani riceverete poi la nostra un'email sempre dalla piattaforma con sicuramente l'attestato di partecipazione e un piccolo sondaggio. Siamo in chiusura di anno, ci piacerebbe ricevere i vostri feedback, ma anche suggerimenti di quelli che possono essere magari gli argomenti per voi interessanti e che vorreste che SRA affrontaste e condivideste con voi. Quindi sentitevi liberi di condividere le vostre magari richieste con noi. Da parte mia grazie, thank you Arian and thank you Tia, e Fabrizio se vuoi chiudere il nostro webinar, a te la parola, grazie.
Sì, non ho molto da aggiungere, devo dire una bellissima esposizione, many thanks Tia, really clear and good steps show to our customers. Aggiungo semplicemente, ricordatevi la possibilità di allontanarvi dall'utilizzo dell'elio, possiamo utilizzare azoto e idrogeno sui due canali, è un'opzione che va semplicemente scelta in fase di configurazione per quanto riguarda le versioni dedicate al gas di raffineria. Direi che è tutto. Vi ringraziamo per la presenza, per il supporto e per la fidelizzazione che ormai sentiamo
Sì.
molto vicina. Questo vale anche per noi nei confronti della nostra distribuita, che ci propone sempre analizzatori di qualità, innovativi, che seguono pedissequamente quello che è richiesto dalle norme e ci presentano aggiornamenti in continuo. Grazie a tutti.
Grazie, quindi
Grazie.
visto che è l'ultimo
Grazie.
appuntamento
Ciao.
prima delle vacanze, auguriamo anche a tutti un buon
Vero.
Natale e delle buone feste.
Buon Natale a tutti.
Grazie, grazie a tutti.
Bye bye.
Bye.
Ciao.
Bye. Ciao, ciao.
Bye bye.
Ciao ciao.